In this discussion video, we will do an approximation example. So this is problem 5b from worksheet 10, and it asks us to approximate negative the fourth root of 250. And then is your approximation an over or under estimate? So first I want to give you 5 minutes to try this problem. 4, 3, 2, 1, pause it and try it for about 5 minutes. Alrighty, so hopefully you did that. Hopefully you paused it and tried it for about 5 minutes. Let's talk about it together now. So when we want to approximate something like this, the idea is we want to use linear approximation. And I first want to identify a function that's sort of underlying here that I could be plugging something into to get this. And that function, based off of this structure, seems to be negative fourth root of x. All right, and the x value that I'm sort of plugging into this is 250. Well, when we do linear approximation, what I need to know, actually maybe it would be helpful if I draw a picture first. So let me draw some axes. So I'll draw some axes. And if I just had the fourth root of x with no negative sign, that looks a little bit like the square root graph. So a little bit like this, if I had y equals just the fourth root of x. So the negative fourth root of x, that would reflect this across the x-axis. Negative fourth root of x, that graph looks like this. So reflected down. Okay, so let me erase the positive fourth root graph. All right, and I want to know what's going on when x is 250. Let me just label that here. All right, so on the graph, that is this point. That is the actual point. So the idea with these linear approximation questions is when I find that underlying function, I try to find a value of x close to this one that I can plug into my function, and I know what it is, a nice value. And that nice value, we call it a. And what's a nice value close to 250 that I know the fourth root of? It's 256. So 256, I'm going to label that on my x-axis. So it's definitely not to scale. I'm just trying to space it out a little bit. 256. I'm going to label that point because I know the fourth root of 256. In fact, let me just put a negative sign in front of it to be my function. The fourth root of 256 is 4. So this is negative 4. That's my y value. Okay, and the idea is at this nice point, we draw a tangent line. So the tangent line is going to look something like this. And if I can find the equation of the tangent line, then I'm just going to plug the 250 into the tangent line equation. That'll give me this point, and that is my estimate. Okay, and typically we're hoping that that'll be pretty close to the actual point. All right, so let's try to get that tangent line. But to get it, I need to know a point, and we need to know the slope. So the point we have already, the x-coordinate of that point of tangency here is 256, and the y-coordinate we got was negative 4. For the slope, I'm going to have to take the derivative. So my function, let's rewrite it as a power. This is negative x to the 1/4. So when I take the derivative, the 1/4 will come down. I'll get negative 1/4 x to the negative 3/4. And now I'll plug in my x value, the 256. And f prime of 256, that's going to be negative 1/4 times 256. If I bring this negative 3/4 to the denominator, it becomes a positive 3/4. All right, so we have negative, let's see, we have a negative 1/4. And then this is the fourth root of 256 being cubed. All right, so negative 1/4. I know the fourth root of 256. We did it already. It was 4. So 4 being cubed. So we have negative 1 over. The denominator is essentially 4 to the 4th. And that's 256. So negative 1 over 256, that is my slope. We are now ready for the equation of the tangent line. So the equation is going to be y minus, the y-coordinate of our point is negative 4. So y minus negative 4. Double negative gives me a positive. So we'll get y plus 4 equals m, my slope, negative 1 over 256, times x minus the x-coordinate, 256. Okay, so that is the equation of the tangent line. Let me just highlight this so it stands out a little bit more. And now we need to plug in the actual x value, the 250, into that tangent line equation, because that'll give me this estimate point. So we are now going to plug in the actual x value, which is 250. Okay, so our equation was y plus 4. Y plus 4 equals negative 1 over 256. And then it was x minus that 256. And now we're going to be plugging in the 250 for the x. So we'll plug in 250 here. All right, so if I simplify this, we get y equals, let's isolate y. So I subtract the 4, and I get negative 4. And then we have minus 1 over 256 times, and then 250 minus 256, that is negative 6. So we get negative 4 plus 6 over 256. I could divide the top and the bottom by 2 and get 3 over 128. And if I get a common denominator with this, the negative 4 becomes negative 512 over 128, and then added to 3 over 128 gives me negative 509 over 128. And if I look back to my picture, we can see that that estimate is going to be an underestimate of the actual point, because this is below the actual point. All right, so this underestimates the actual value